Alright, folks. Hello, it's Miss Scott doing the first Visci makeup video. This is covering what we covered on December the 9th, 2013. Please disregard that banging noise. That is my son, who, despite how adorable he is kind of loud sometimes. So just please bear with me, and we'll have a great day. Alright, so December 9th, 2013, the words of the day. The words of the day are work and power. Work and power. So what does that mean for us in physical science class? So we're going to do a little bit of notes first, and then we're going to do a little bit of calculations, and hopefully you'll get it all. You'll be able to... Guys, JJ. So hopefully you'll be all super duper ready for your test, which happens to be on Friday, which I know is coming up really, really soon. It's the 13th, and today's the 10th. OMG. Alright, let's do this thing. So work. You need to know what the definition of work is. The definition of work is the force, or excuse me, not the force, the product of a force, that's an E, ladies and gentlemen, that's how I write my E's, product of a force over a distance. So you have two things here, you have two variables here, you have force and distance. You need to know that. Ladies and gentlemen, you have force and distance. Force, I'm going to make a side note, force is measured, it says measured in, and what you really need to know, newtons. Force is always measured in these things called newtons. We've talked about them before. That's the same thing that you measure weight in. Weight, mass times free fall, and if you're doing Newton's second law, force equals mass times acceleration, same thing, that force. Distance we always measure in meters. Obviously, that kind of makes sense. You measure how far something away is with a meter stick. That's important. I'm never going to try to trick you on a test with saying something moves over a certain amount of, with saying something moves over kilometers or centimeters or something like that. But please know you have to change to whatever it is to meter. So if you're given kilometers, that's km. All you would do is times that number by 1,000. That would equal meters. If you were given something like centimeters, centi, 100, like a century, you would just divide that by 100, and that would equal meters as well. Good stuff to know. Good conversions to know. I don't know if they'll give that to you on your state test or not. I'm not going to bother tricking you with that. I don't really care if you can convert right now. What I care right now is work and power. So, product of a force over a distance. So let's do a little bit of calculations. So if I have a force, remember force is just something that pushes or pulls. Oh, and before we do actual calculations, thank you for reminding me, Miss Scott. You're awesome. A few rules of work. The force and direction, oh wow, heavens to Betsy. The force and distance have the same direction. So they're going the same way. So if I'm pushing something, my force is going that way, and whatever I'm pushing is going that way as well. If I am lifting something up, the force is going upwards, and whatever I'm lifting is going up as well. The same direction. So something you might see, some things they might ask you, is this work, yes or no? Please make sure that the force and distance have the same direction, and make sure there is distance involved. If I push on a wall, if I push against a wall and obviously it doesn't move, that's not technically work. And in physics world, that's not work. Even though you felt like you did work, it's not this work. And this is the work we care about. Me sitting here talking is not technically work. Am I using energy? Yeah, but It's not this work. I'm not applying a force over a distance. So, what else? I'm not getting paid for this either. It's because I love you. Alright. So, with that being said, we can do some calculations now. We can do some super easy calculations. Remember, and I'll put it right here, work equals force times distance. So if I tell you that I have a dog, I have a puppy dog, and it is a sled dog. Let's say it's a sled dog. Do I have a sled dog? No, I don't. Would I like one? Yes, please. So let's say it has a sled attached to it, and this sled weighs, I don't know, let's say it weighs 500 newtons. So my force is 500 newtons. It's going to take that much force to move it. I can't move it with any less force. If I move it with more force than that, you have greater acceleration, but we're not going to get into that. I don't care. It takes 500 newtons to move it. And my sled dog moves 30 meters. 30 meters. In order to solve that, that's super duper easy. Super duper easy. You have both these variables. You just plug it in to solve. So I'm going to say 30 meters, that's my distance, times 500 newtons. It doesn't matter which order they go in because it's multiplication. It's the same either way. So I know 30 times 300 is going to be 15,000. Yes, 15,000. 15,000? Yes, 15,000. Okay, just making sure I got my math right. So 15,000. Now, I put meters here and I put newtons here. I need to put something here as well. I need a unit with this. You can't leave something without units. That's really, really, really annoying. Don't do that. Work, the unit of work are these thingermajigs called joules. And you need to know that word. So I'd write that down somewhere, put a great big star by it, highlight it, circle it, a little heart next to it, something. Just so you know that is super, super, super important, joules. So my sled dog did 15,000 joules of work pulling that 500 Newton, whatever it was, over a distance of 30 meters. Okay? And we'll keep practicing, no frets. So don't let this video go over 10 minutes, so I have like 2 minutes to explain power. But that's okay. So power. So when we think of something power in physics, power is the rate at which you do work. So how long it takes you to do a certain amount of work, what the rate of work is. So speed is the rate of distance over time. Power is equal to work over time. Again, work is always measured in joules. Time for our physics, for our purposes, hi JJ. Time is always measured in seconds. And power is this thing you probably heard of before. There are these units called watts. Yay, watts. Like light bulbs. Like wattage. Yay, no bigs. Okay. So work divided by time. That's all power is. So we're going to go back here to my sled doggy dog. He's adorable. Let's say, and I'm just going to make an easy number to make my life easier because I don't have my calculator with me. Let's say it took him 10 seconds to get this far. He's a really, really fast sled dog. He went 30 meters, pulling 500 newtons of force behind him in 10 seconds. All I would do, I would take my work, 15,000 joules, divided by 10. If you did not know this already, when you divide things by like tens or hundreds, all you have to do is cancel those zeros out. And that leaves me with 1,500 watts of power. That's how much power it was exerted.